This video focuses on trigonometry applications. You can find it in your text in section 8-7. First of all, let's go over some terminology. We have two new terms that we're going to be using in this section, the angle of elevation and the angle of depression. And rather than defining those terms in words, I think it's best if you just copy this diagram into your notes. We have a stick figure here. He's looking upwards at an object, and he's looking downwards at an object here. The angle at which he's looking upwards is the angle of elevation of this object, of his line of sight, rather. The angle at which he's looking downwards, maybe into a valley, or maybe he's standing way up high in a tree. He's looking downwards at the angle of depression. And one thing that I want you to add to this diagram is I want you to write the word horizontal on this horizontal line. And that will remind you that we're always measuring the angle of elevation and the angle of depression from the horizontal. We're imagining that this stick figure is first looking at the horizon. That's where the word horizontal comes from. He's looking straight out at the horizon, and then he's glancing upward at this object by an angle amount that's the angle of elevation, or he's glancing downward by the angle of depression from the horizontal. This is so that you don't get confused and accidentally think that this angle here is the angle of elevation. That is not the one we're looking for. We're looking always for the angle between the horizontal and the line of sight. You can even label this line here the line of sight. Okay, once you have this diagram copied, we're ready to move into our problems. Here's a first example. When the sun's angle of elevation is 57 degrees, a building casts a shadow 21 meters long. How high is the building? Okay, well, we certainly have to draw a picture here. I'm going to make my building somewhere in the center here. I'm going to make the sun way up high in the sky, and the sun's rays are striking the top of the building and continuing downwards till they reach the ground. And the angle of elevation, which is always the angle with the horizontal, in this case is 57 degrees. As we've learned in class with our experiment the other day, the building's shadow, the length of the shadow, is going to be measured from where the sun touches the top of the building here to the place where the sun's ray touches the ground over here. So the shadow in this case is 21 meters long. And the other piece of information we have is that the building makes a right angle with the ground. So now we have a triangle made out of the shadow, the building, and the sun's ray along the hypotenuse. We're interested in how high the building is. So I'm going to put my X here. X is measuring the height of the building. So if we look at this right triangle that we've just formed, and we think about our trigonometric ratios, we have this angle 57 degrees. We know something about one of the legs of the triangle, and we want to know something about the other leg. We don't really care much about the hypotenuse in this triangle. So the best trig function to choose is tangent here, because the tangent is opposite leg over adjacent leg. The tangent kind of ignores the hypotenuse of this triangle, which is exactly what we want to do. So the tangent of our angle that we're given, which is 57 degrees, is going to be the measure of the opposite side, opposite from 57 degrees, and that's x, over the adjacent leg, which is the length of the shadow along the ground. So that's 21. Multiplying both sides of this equation by 21, we have 21 times the tangent of 57 equals x. Then we can look up in our trig table the tangent of 57. Go all the way over to the third column, and the tangent of 57 is 1.5399. So plugging that in for the tangent of 57, 21 times that number is x. When I plug this number into my calculator, I get a value something like 32.3 something something something, and the problem isn't telling me how I should round the number, but since they're giving me 21 meters, I'm going to round this to the nearest whole number. So I'm going to give my answer as 32 meters. Okay, you try. At a certain time, a vertical pole 3 meters tall casts a 4-meter shadow. What is the angle of elevation of the sun? Let's do one more example. A kite is flying at an angle of elevation of about 40 degrees. So I'm going to make my kite string and my kite way up high in the sky. Here's the ground. Well, the ground is probably somewhere down here because somebody has to be holding the kite. So I'll make my stick figure holding the kite. The angle of elevation is about 40 degrees. So since the kite is being held up in the air, I'm going to make a horizontal line because we always measure the angle of elevation from the horizontal. This is 40 degrees. And all 80 meters of string have been let out. So I'm going to label the length of the string 80 meters. Ignoring the sag in the string, so we're considering this a straight line, find the height of the kite to the nearest 10 meters. So what we're being asked to find is this height here. And because it's to the nearest 10 meters, we really don't have to worry about the fact that the kite is starting out a few feet above the ground, because to the nearest 10 meters gives us a lot of room to ignore that small amount of distance. So we could consider this height being almost the same as the height all the way to the ground. Okay, so we're going to use trig to solve this again. We're given an angle and a side of a right triangle. This time we are given the hypotenuse, and we're interested in finding the opposite side. So the best trig function for me here is going to be sine, which is opposite over hypotenuse. So I'm going to write down the sine of 40 degrees equals the opposite leg, which is h, over 80, which is the hypotenuse. Multiplying both sides of this equation by 80, I have 80 times the sine of 40 degrees equals h. Now I need to look up 40 degrees in my trig table, and I need to follow that over to the sine column. So I have my number here, my sine ratio is 0.6428. And I have 80 times that is going to be my height. The number that I'm getting is 0.4 something something something. But remember, I'm being asked to find to the nearest 10 meters. So I don't even have to round off to 51. I can use this tens place, which is less than 5, and I can round off to 50 meters for my answer. You try one like this. An advertising blimp hovers over a stadium at an altitude of 125 meters. The pilot sights a tennis court at an 8-degree angle of depression. Find the ground distance between the stadium and the tennis court to the nearest 100 meters. For further practice, see page 319, numbers 5, 9, and 11.